So what I would want to do today is take up that quadratics quiz number 1. So looking at the first question, it asks us for the vertex of this relationship. So the vertex is that turning point, so it's at 2, 1. The direction of opening is either up or down. That's all we have to say. And in this case, the parabola opens up because the opening is up. The max or the min value, that's the highest or the lowest value. So that's a y value, that's our optimal value. And in this case, it's a minimum and it's y equals 1. The axis of symmetry is that line down the middle that splits the parabola, and it is at x equals 2. And now the equation always looks the same, right? The equation always looks like y equals x minus something squared plus something, and there might be a stretch factor there. So in this case, there is no stretch factor because the step pattern is over 1 up 1, over 2 up 4. We can read that off the graph. It's moved 2 to the right, and it's moved 1 up. So that means that the equation is like that. That 2 moves it to the right, this 1 moves it up, and that's it. We can get this information right from the vertex, right? Okay, so write an equation of a parabola that has vertex 2, 1. So again, if it has vertex 2, 1, we can write this about it, because move 2 to the right and 1 up. So that's all from the vertex. Now we have to use that second point, 3, negative 7, and we can plug that in for the x and the y value to find a. So we plug it in, and a lot of people got this far and then they stopped. Well, we have to find out what a is to write the proper equation, right? This is the equation. We just have to make sure we have all the pieces. So we're missing a, so let's simplify and solve. So brackets first, 3 minus 2 is 1, and then exponents. 1 squared is 1, so it's just 1a plus 1. Subtract 1 from both sides, and we get negative 8 is a, and now we can write our equation. Negative 8, x plus 2 squared plus 1. So when I ask for an equation, it has to look like this, if it's in vertex form, or it can be in factored form too. Okay, so we're given an equation in factored form, right? We have to know the difference. If there's a square in the equation, then it's vertex form. It tells us the vertex. If there's no square, if there's two brackets multiplying each other, that's factored form. That tells us the x-intercepts. So, first let's label our grid. Good, now we know we're going by ones. So this gives us an x-intercept at negative 3, 0. Let's plot that. Then we have another x-intercept at 6, 0. We'll plot that. Now let's find our axis of symmetry. Well, the axis of symmetry is right down the middle, and you guys decided that we could add the two numbers and divide them by 2. So add the two x-intercepts and divide them by 2. Negative 3 plus 6 divided by 2 is 1.5. So there's our axis of symmetry right between 1 and 2. So that tells us that there's a vertex at 1.5 and something. I want to know what that y value is, but we know the x value is 1.5. So to find that y value, we can just take x and plug it into this original equation here, right? So if we plug it into that original equation, this is what we get. And then we just simplify and we multiply everything, and that's 10.125. So now we can take that point and plot it. Well, we can write down the vertex, it's 1.5, 10.125, and then we plot that point right there. We can even label it so we're sure, and then we can draw our parabola. Okay, so factored form, we need 3 points, 2 x-intercepts and a vertex. Okay, alright, let's see graphing. So this is vertex form, right? Here, there's that little square there, and that tells us where the vertex is going to be. So if we want to write down the vertex, it's at 3, 5, because it's moved 3 to the right, 5 up. And then it says sketch a graph of the above function, or above quadratic, as well as y equals x squared. So let's start with y equals x squared, because we know what that one looks like. It's got a vertex at 0, and it goes over 1 up 1, over 2 up 4. That's our base graph. Okay, so we have to know how to sketch that. Then to do the next one, we know that the vertex is at 3, 5, so we'll plot it there. And then we have to check the step pattern. So the regular step pattern is over 1 and over 2, and we'll look, if it goes over 1, it goes up 1, and over 2, it goes up 4. Remember, this is because 1 squared is 1, and 2 squared is 4. Right? Now we want to see what happens to the step pattern of negative 2x squared. Well, we know that all we're going to have to do is multiply these guys by negative 2. Right? So if we multiply them by negative 2, 1 times negative 2 is down 2, and 4 times negative 2 is down 8. Right? So we can plot our points, over 1 down 2, over 2 down 8, and then we can sketch our parabola. So that's it. So graphing from vertex form involves the vertex and then the step pattern. Okay? Alright, so this one says a football is kicked into the air and follows this equation. So first, it says a rough graph will be helpful. We should always know how to draw a rough sketch. Okay? So the rough graph says that there's a vertex at 319. So that's what I plotted. And then we can say that when the ball is kicked, it'll look something like that, just because that's what the motion of the ball looks like, right? It goes up and then down. So this question is, when does the football reach its maximum height? Well, when does it reach the maximum height? That's the t value, right? So we're looking for t, so that means the axis of symmetry. The axis of symmetry is t equals 3. So that means 3 seconds. The maximum height, well, the height is a y value. So that means we're looking for the maximum, or the optimal value. And in this case, it's h equals 19. So that means 19 meters. Now, when's the ball punted? When it's first kicked, we know the time. When it's first kicked, we know that it's been 0 seconds. Right? Right when I kick it, 0 seconds has gone by. So we can use our original equation, except instead of t, we're going to put 0, right? So negative 2 and then 0 minus 3 squared plus 19. So this is the original equation, but we've subbed in t equals 0, okay? So now we just simplify. 0 minus 3 is negative 3, and then negative 3 squared is 9, and then negative 2 times 9 is negative 18, and negative 18 plus 19 is 1. So this says that it was 1 meter high when it was first kicked. Alright, so let's look at this question. Refer back to the graph at number 4 and describe using terminology the transformations. So, there's an x minus 3. We know what that minus 3 does. That minus 3 horizontally translates the graph 3 units to the right. So it's horizontal translation 3 units to the right. There's also a plus 5. That plus 5, vertical translation 5 units up. Right? There's also a multiplier of 2. So that 2 is a vertical stretch by a factor of 2. And there's also a negative sign there. And that negative sign is a vertical reflection, and that's it. Okay, so this is really important. This was done on the first day of quadratics. We have to know this terminology. Okay? Okay, now we want to use this chart to explain whether the relation is linear, quadratic, or neither for number 7. So remember, the only way we can see if something's linear, quadratic, or neither is first and second differences. Right? So to calculate the first difference, we're going to go negative 1 minus negative 3. So we're going to subtract the two y values. That gives us 2. Then we're going to go 2 minus negative 1. That gives us 3, and so on. Right? To get the second differences, all we're going to do is we're going to subtract the first differences. So first one's going to be 3 minus 2, and that's 1. And then the next one's going to be 4 minus 3, that's also 1, and so on. And now we should recognize that the second differences are the same. And based on that, we can write our conclusion. The relation is quadratic because the second differences are the same. If the first differences were the same, that would be linear. You learned that in grade 9. If none of them were the same, then it would be neither. Okay? Alright, so it says there are three parabolas. One of them has two x-intercepts, one of them has one x-intercept, and one of them has no x-intercepts. Write down the equations and how many intercepts they have and explain how you know. Alright, so let's look at two x-intercepts first. So if it's two x-intercepts, we know that it has to go through the parabola twice. So this is a possible graph. Now if we just think about what an equation of this might be, well, it's a parabola that's been shifted down by whatever number of units. So a possible equation is y equals x squared minus 1. Right? So x squared minus 1, the vertex is below, right? So we can say vertex is below the axis and it opens up. So it has to go through the axis twice because the parabola has two arms, two symmetric sides. Okay, if we want to look at only one x-intercept, well, remember we talked about it's got one x-intercept if the vertex is right on the axis. So it'll look like that. This thing only has one x-intercept, and that could be our base parabola, x squared. So here, the vertex is on the axis, right? Okay, and no x-intercepts, well, we can draw a graph that looks like this, right? That's got no x-intercepts, and that could be just a parabola translated 1 unit up, right? So the vertex is above, and it opens up, so it's never going to come back down. Okay, so that was a little bit of thinking for the quiz.